Good evening, everyone. Let's just wait for 5 more minutes so that if anyone wants to join the meeting can join. I guess we can start now. So I hope you all must have gone through the lecture videos and studied the theory that has been built in order to solve some differential equations. And you must have got your assignment questions as well. So today we'll be doing some questions that are similar to those given in your assignment. Basically, we'll be solving some higher order differential equations today. We'll see various methods using which we can solve higher order differential equations. So let's start. First question. Solve y triple derivative of y minus 3y double dash plus 4y equals to 0. If you remember in last class, we had done some similar kind of questions where we took yx is equal to some constant, some e to the power some constant times x, this function as a solution, and using this eventually we got an auxiliary equation, and with the help of that auxiliary equation, roots of the auxiliary equation, we got the solution. So from now on we'll be directly writing the auxiliary equation. So for this equation, the auxiliary equation is given by r cube minus 3r square plus 4 equals to 0. Now we can see that this is a cubic equation. So in order to find the roots of such an equation, we don't have some generalized method. We don't have any certain method to solve a cubic third order equation. So here we can see that if we take r equals to minus 1, then clearly the left hand side is minus 1 cube minus 3 plus 4, which is again 0, right hand side. Therefore r equals to minus 1 is a root for this equation, or we can say the root of this polynomial. Now if we divide this polynomial by r plus 1, r cube minus 3r square by 4, we get r square r cube plus r square minus minus 4r square plus 4 minus 4r minus 4r square minus 4r plus we get 4r plus 4 and 4. Therefore, we can write first can be written as r plus 1 times r square minus 4r plus 4 equals to 0. Now this is r plus 2 whole square. So we have r plus 1 and r minus 2, r minus 2 square equals to 0. From here we get the roots to be minus 1 to 2. So we all know that when we have repeated roots and we have distinct roots, we can easily write our solution as, in this case, our solution would be c1 e to the power minus x plus. Now this 2 is a repeated root. In that case, we have c2 plus c3 times x e to the power 2x. This is the final solution. I hope you all must be clear with all the steps that had been used in order to solve this question. Not much tactics required. Okay, let's move to the next question. Solve the fourth derivative of y plus a power 4y equals to 0. Solution. Now the auxiliary equation given by r power 4 plus a power 4 equals to 0. This gives us r power 4 is equal to minus a power 4. This gives us r is equal to a fourth root of minus 1. So if you go back to the complex analysis course that you all must have done, uh, the roots, the value of r is a e to the power iota pi by 4, a e to the power iota 3 pi by 4, a e to the power iota 5 pi by 4, and a e to the power minus iota pi by 4. That means r is equal to a 1 plus iota by root 2, a 1 minus iota by root 2, a minus 1 minus iota by root 2, and a minus 1 plus iota by root 2. So we have two pair of conjugate roots. So our solution to this homogeneous fourth order differential equation is yx is equal to e to the power a by root 2x times c1 cos x plus c2 sin x. cos x by root 2 sin x by root 2 plus e to the power minus a by root 2x c3 sorry inside cos we should have the imaginary part, and the imaginary part is a by root 2 times x plus c2 sine a by root 2 x here again c3 cos a by root 2 x plus c4 sine a by root 2 x. So this gives us the general solution to our fourth order homogeneous differential equation. I hope all the steps were clear. The main important thing in this question was whether you know what do we mean by fourth root of unity. This question was mainly to revise, recall you what how do we calculate the nth root of unity. So it would be better if you go back to whatever you had, whatever notes or books you had read while going through the complex analysis course, and see again how do we calculate the nth root of unity. Okay, then let's move to the next question. Now we'll be using the method of undetermined coefficients to solve a higher order differential equation which is not homogeneous. That means we now till now we were dealing with homogeneous type of equation. On the right hand side in both the cases we had 0. Now we'll see what happens when we don't have the when we don't have 0 on the right hand side. That means the non-homogeneous case. So solve by the method of undetermined coefficients. Problem is double derivative y minus y dash minus 6y is equal to 20 times e to the power minus 2x. Now in order to solve this, we'll start with the homogeneous part of this problem. So and the solution of that homogeneous part is called the complementary function. So our first aim is to find the complementary function. For that we need the auxiliary equation. So now our auxiliary equation is given by r square minus r minus 6 is equal to 0, which is r square minus 3r plus 2r minus 6 is equal to 0. R minus 3 plus 2 r minus 3 is equal to 0. So the roots are minus 2 and 3. So the solution of the homogeneous part, which we call as the complementary function. The complementary function we will denote it as ycx is equal to c1 e to the power minus 2x plus c2 e to the power 3x. Now we will try to find we'll try to find a solution of equation 1 which is linearly independent to these and somewhere related to this non-linearity. So we'll start with the hit and trial method. We'll consider, let ypx. Now what is the nonlinearity? E to the power minus 2x. We know that e to the power minus 2x is already here. We want something which is linearly independent. So we'll take ypx to be some constant times x e to the power minus 2x. So now we'll find this A, so that this yp is a solution of our equation first. How we will find that? We'll just take the derivative, double derivative of ypx, and see for what value of A the equation 1 is satisfied. Now this gives us yp dash x is equal to A, x as it is, e to the power minus 2x times minus 2 plus e to the power minus 2x, which can be written as A e to the power minus 2x 1 minus 2x. This gives us yp dash, which implies yp double dash x is equal to A e to the power minus 2x as it is minus 2 plus 1 minus 2x as it is e to the power minus 2x times minus 2, which is e to the power minus 2x A x minus 1, sorry, x minus 1, 4, 4a. So now let's just put the values of yp double dash, yp dash, and yp on the left hand side of the equation, and see how we'll get the right hand side. That means we want it should be equal to 20 e to the power minus 2x. Now LHS is equal to yp double dash minus yp dash minus 6yp is equal to e to the power minus 2x x minus 1 minus a e to the power minus 2x 1 minus 2x minus 6a x e to the power minus 2x, which is equal to a e to the power minus 2x 4x minus 4 minus 1 plus 2x minus 6x. This 2x plus 4x is 6x, which gets cancelled out. We are left with minus 5a e to the power minus 2x. And what was in our right hand side? 20 e to the power minus 2x. Now, what should we take the value of a? Taking a to be equal to minus 4, we are done. This implies ypx is equal to minus 4x e to the power minus 2x. Now this solution, the general solution to our problem is given by, therefore our general solution yx is given by ycx, the complementary function, plus ypx, the particular solution. We all know that, we have seen that this ypx is a specific function that satisfies the equation. That is why we are calling it as particular solution. Now this is equal to c1 e to the power minus 2x plus c2 e to the power 3x minus 4x e to the power minus 2x. This is our general solution. This method of finding particular solution is called the method of undetermined coefficients. We are basically taking some coefficients. Here we took a and try to find the value of a so that it fits to the equation. And using that particular solution and the complementary function, we get our general solution. Now let's move to the next question. Solve by the method of undetermined coefficients. The equation y double dash minus 4y dash plus y is equal to x square minus 2x plus 2. Again, we'll start with finding the solution to the corresponding homogeneous equation and call it as the complementary function. So for that, we need our auxiliary equation. So the auxiliary equation, let's number it 1. Auxiliary equation for the homogeneous equation corresponding to 1 is given by r square minus 4r plus 1 equals to 0. Now we all know how to solve a quadratic equation, how to find roots of a quadratic polynomial. We start with finding a discriminant, and using that we find the roots. So here we get r is equal to 4 plus minus under root 16 minus 4, we get 12 by 2, which is basically 2 plus minus root 3. So now we have two distinct real roots. So in that case, our solution is given by, and we'll call that solution as the complementary function. The complementary function ycx is given by c1 e to the power 2 plus root 3x plus c2 e to the power 2 minus root 3x. Now we need to find the particular solution. It should be linearly independent to both these functions and somewhere similar to this non-linearity. So clearly this non-linearity is a polynomial, and these functions are exponential functions. So they are linearly independent. We can take the solution to be some polynomial. So let ypx is equal to some quadratic polynomial. Now we'll find the value of this a, b and c so that this yp becomes the exact solution to our problem 1. So again, we'll find the derivatives. Yp dash x is equal to b plus 2cx and the double derivative of yp is 2c. So this gives us our LHS was y double dash minus 4y dash plus y, which is 2c minus 4b plus 2cx plus a plus bx plus c x square. So we'll just separate the coefficients of x square and the constant term. So here we have with x square just c, with x we have minus 8c plus b, and the constant terms are a minus 4b plus 2c. And our RHS was x square minus 2x plus 2. So this gives us that c is equal to 1, which implies c is equal to 1 and b minus 8c is equal to minus 2. Now this implies, now since c is equal to 1, we get b is equal to 6. b is equal to 6. Also comparing the constant terms, we get a minus 4b plus 2c is equal to 2, which gives us a is equal to 2 plus 4b. b is 6, so 4 times 6 is 24 minus 2c, 2. This gets cancelled out. We get a is equal to 24. Therefore, therefore, by px x square plus 6x plus 24. And our general solution was given by cx plus by px. So, general solution for equation 1 is given by x is equal to by cx plus y px, which is c1 e to the power 2 plus root 3x plus c2 e to the power 2 minus root 3x plus x square plus 6x plus 24. And this is a general solution to a problem. So I hope all the steps were clear enough. The method we have used here is exactly same what we had done earlier. Firstly we start with finding the complementary function, that is the solution to the corresponding homogeneous equation, and for that we find the roots of auxiliary equation, and on the basis of the type of root that we have, we get the complementary function. The next aim is to find the particular solution. So while using the method of undetermined coefficient, we take some function with some coefficient, arbitrary coefficient, that would get we would be deducing further. We take this yp function such that it satisfies our equation. So just putting it into the function, into the equation, and then finding the value of coefficients, we get the particular integral, and hence using the complementary function and the particular solution, we get a general solution. And that is why, since we are trying to find the coefficient, we call this method the method of undetermined coefficient. Okay, till now we had everywhere we had seen in our problems that the derivatives were linear, or we can say that there was nothing multiplied to this derivative. Now we'll see how to deal with the problem when we have some x square or x cube type of terms multiplied with the derivatives. Okay, let's go to the next question. Question number 5. Solve x cube y triple dash plus 2x square y double dash plus 2y is equal to 10x plus 1 by x. So if we didn't had this x cube, we could have very easily solved this problem again by finding the complementary function and the particular integral. But now the problem is that how to find the complementary function. For the complementary function, we need to find the roots of auxiliary equation. But here, our auxiliary equation will contain some x square type of terms as well. That would create a problem. So now we'll try to do some substitution so that our problem becomes similar to the one that we have been solving till now. Solution. So let's take x to be equal to e to the power t. This gives us a t is equal to log x. Now this gives us dt by dx. I'll write it there. This implies dt by dx is equal to 1 by x. Now we'll try to convert our problem, which was in x and y, to a problem in t and y. So dy by dt would be dy by dx and dx by dt. We want to replace dy by dx. Now this dy by dx is equal to dy by dt and times dt by dx. This is a basic chain rule, which is 1 by x dy by dt. And similarly, this gives us that d2y by dx square would be, now we'll be using the product rule. 1 by x as it is, derivative of dy by dt with respect to x. So we'll get d2y by dt square times dt by dx plus dy by dt as it is, derivative of 1 by x is minus 1 by x square. This will give us, again since dt by dx was 1 by x, we'll get 1 by x square d2y by dt square minus dy by dt. Now substituting the value of dy by dx and d2y by dx in equation 1, also the value of x, we get 1 by x square y double dash minus y dash plus 2x. Oh, sorry, we need third derivative as well. Okay, we need to calculate the third derivative also. This gives us, again we'll be using the product rule, 1 by x square as it is. Now derivative of this term with respect to x will get d3y by dt cube times dt by dx, which is 1 by x, minus derivative of dy by dt with respect to x. So we'll get d2y by dt square times again dt by dx, which is 1 by x, plus d2y by dt square minus dy by dt times the derivative of 1 by x square, which is minus 2 by x cube. So now we'll be substituting the value of d3y by dx cube, d2y by dx square, dy by dx and x in equation 1. So from there we'll get x cube times this, what is this, x cube y triple dash minus y double dash plus minus 2y double dash plus 2y dash. Then we have 2x square by x square y double dash minus y dash. Then we have 2y. 2y is equal to 10x plus 1 by x. 10 x is e to the power t, 1 by x is e to the power minus t. And everywhere this x gets cancelled out. So we are left with triple derivative of y, minus 3 plus 2 would be minus y double dash plus 2y is equal to 10 e to the power t plus e to the power minus t. Now this is a type of problem that we have been dealing till now. So again we'll find the complementary function, the particular solution. Everywhere the solution would be a function of t, and at the end we'll be replacing the value of t by e to the power value of t by log x. So now our auxiliary equation, we'll start with finding an auxiliary equation, which is r cube minus r plus 2 equals to 0. Again, this is a cubic polynomial. We don't have standard rules to solve such an equation, but still here we can see that r equals to minus 1 will satisfy, because for r equals to minus 1, LHS is minus 1 cube minus plus 1 plus 2. Sorry, this is r square. So this will be minus 1, which is 0, which was our RHS. So clearly r equals to minus 1 is a root. So we can just divide this polynomial r cube minus r square plus 2 by r plus 1. From here we get r square, r cube plus r square minus minus, minus 2r square plus 2 minus 2r minus 2r square minus 2r plus plus 2r plus 2 plus 2. So we can write the second. This implies second can be, the equation 2 can be written as r plus 1 r square minus 2r plus 2 is equal to 0. This gives us r is equal to 1, and the root of this quadratic part is given by 2 plus minus under root. Discriminant would be 4 minus 8 by 2, which is 2 iota. This is 1, 2 plus minus 2 iota by 2, or we have r is equal to 1 and 1 plus minus iota. So we have three distinct roots. Sorry, r equals to minus 1. One of them is real, and rest of the two roots are conjugate. So in that case, our complementary function ycx is given as c1 e to the power minus x plus e to the power x c2 sin x plus c3 cos x. Sorry, the variable here was t, not x. We'll be replacing the value of t in terms of x at the end. So now our next aim is to find the particular integral. Particular integral is a function yp such that d cube minus d square plus 2 yp is equal to 10 e to the power t plus e to the power minus t. So by d, we mean the derivative operator. So this yp is equal to 10 e to the power t by d cube minus d square plus 2 plus 10 e to the power minus t by d cube minus d square plus 2. So to find particular integral of this specific type of function when the nonlinearity has e to the power some constant times t, in that case we find the particular integral by just putting the value of this constant that is multiplied by this variable t. Here it is 1. So if we put d equals to 1 in the denominator and the denominator turns out to be non-zero, then that gives us the particular solution. So here we can see that d equals to 1 will suffice. So 10 e to the power t plus 3 minus 1 is 2. But in this case, we cannot put the value of d equals to minus 1 because d equals to minus 1 is a root to the denominator and it will make the denominator 0. In that case, we'll just multiply it by t and then differentiate the denominator with respect to d. We get 3d square minus 2d. And again, we'll see that whether this putting the value of d equals to that constant makes the denominator non-zero. And here, if we put d equals to minus 1, we get 3 plus 2, which is again non-zero. So in the next step, we can just put the value of d to be minus 1 and hence we'll get the particular integral. This gives us 5 e to the power t plus 10t e to the power minus t by 5. Therefore, our particular integral by t is equal to 5 e to the power t plus 2 t e to the power minus t, which implies that our general solution yx, which was ycx plus ypx, is equal to e to the power t c properly c1 e to the power minus t plus e to the power t c2 sin t plus c3 cos t plus 5 e to the power t plus 2t e to the power minus t. Now we know that t is equal to log x. Replacing the value of t in terms of x, we get yx is equal to c1 e to the power minus log x, which gives us x to the power minus 1. So c by c1 by x plus e to the power log x is x, c2 sine log x plus c3 cos log x plus 5 e to the power t. So it's 5x plus 2 log x e to the power minus log x is 1 by x. So this is our general solution. I hope the solution was fine with everyone. You all must have understood all the steps that we had taken. The main important thing here was the particular integral. This is a specific way of finding particular integral. One can easily check that this function will, sorry, not particular integral, but particular solution. So this function will satisfy the equation. One can easily see that. Okay, let's move to the next question. Solve x plus a square y double dash minus 4x plus a y dash plus 6y is equal to x. Now to follow the same method as done in the previous question, we'll start with the substitution. T is equal to x plus a. So that would give us dy by dx is equal to dy by dt. So in that case, our equation first becomes t square y double dash minus 4t y dash plus 6y is equal to t minus a. Now we'll again use the same method as done earlier. We'll take some variable z to be equal to log t. This gives us dz by dt is equal to 1 by t dy by dz and d2z by dt square is equal to, again using the product rule, we get d2y by dt square minus dy by dt. Now putting the values of dz by, sorry, dy, oh, let's write it again. So from here we get dy by dt is equal to dy by dz times dz by dt, which was 1 by t. Dz by dt is equal to 1 by t. And d2y by dt square is equal to 1 by t as it is. d2y by dz square, derivative of z with respect to t, 1 by t, plus dy by dz as it is. Derivative of 1 by t would be minus 1 by t square, which gives us 1 by t square d2y by dz square minus dy by dz. Now putting the values of dy by dt and d2y by dt square in equation 2, we get t square and t square gets cancelled out, y double dash minus y dash minus 4t and t gets cancelled out, y dash plus 6y is equal to, now what was t? T was e to the power z minus a. Now we can write it in plus 5y dash plus 6y is equal to e to the power z minus a. Now we are again in the framework of second order differential equation. Non-homogeneous equation, we'll find the complementary function and the particular solution, and the linear combination, and the general solution will be given by the complementary function plus the particular solution. So for complementary function, let's start with the auxiliary equation. So the auxiliary equation for this problem, write it as number 3. Auxiliary equation would be r square minus 5r plus 6 is equal to 0. This gives us r square minus 3r minus 2r plus 6 is equal to 0. R minus 3 minus 2, r minus 3 is equal to 0. So our roots are 2 and 3. So a complementary function, complementary function ycx is equal to c1 e to the power 2, not x. We were working with the variable z. C1 e to the power 2z plus C2 e to the power 3z. So our next aim is to find the particular solution. So again we'll use the same method as done earlier, because the non-linearity we have is some power of exponential. So the particular solution is given by e to the power z minus a by d square minus 5d plus 6. Again, if you put d equals to 1, the denominator is non-zero. So this is e to the power z by d square minus 5d plus 6 minus a by, let's take 6 to common, 1 plus d square minus 5d by 6. So I hope you all know the expansion. 1 plus x to the power minus 1 is equal to 1 plus x square and so on. So we'll be using this expansion. So the first term, the value of d to be equal to 1, we get 7 minus 5, 2 minus 1 by 6. Let's expand this. We get 1 plus d square minus 5d by 6 and rest of the term times a. Now this is a constant. When we apply this operator on this constant, clearly it will be 0, because the first derivative itself is 0, and then second derivative and higher order, all the derivatives would turn out to be 0. So we are left with z by 2 minus a by 6. So ypz is equal to e power z by 2 minus a by 6. Therefore our solution yz is equal to ycz plus ypz is equal to, what was yc? C1 e to the power 2z plus C2 e to the power 3z plus e to the power z by 2 minus a by 6. Now we know that z is equal to log t, which gives us yt is equal to C1 t square plus C2 t cube plus t by 2 minus a by 6. And what was t? T was x plus 2. So this gives us yx is equal to c2t cube plus c1t square, sorry, c2 x plus a cube plus c1 x plus a square plus x plus a by 2 minus a by 6. This gives us the general solution. So till now we all are now familiar with higher order differential equations. We all know how to solve it. Our aim is to find the complementary function and the particular solution, and there's some will give us the general solution. So I'll just give you next question and wait for 5 minutes so that you can just think if you can solve this problem or not. I'll just wait for 5 minutes. So the method that we'll be using to solve this problem is called the method of variation of parameter by using the method of variation of parameter. I think you must have seen some examples related to this in your lecture videos. Variation of parameters. So again, our first step is to find the complementary function. So for that, our auxiliary equation is r square plus a square is equal to 0. This gives us r is equal to plus minus a iota, which implies our complementary function ycx is equal to, since the real part is 0, we have just c1 cos ax plus c2 sin ax. Now, the method of variation of parameters says that the function ypx given by some function y1x plus v2x y2x, where y1 and y2 are the two linearly independent solutions for the homogeneous equation. So here our y1x is cos ax and y2x is sin ax. Moreover, these functions v1 and v2 are such that they satisfies the following two equations. The first one is v1 dash y1x, which is cos ax, plus v2 dash x y2x, which is sin ax, must be equal to 0. And the second equation says that v1 dash x derivative of y1x, which is a minus sin ax plus v2 dash x and derivative of function y2, which is a cos ax. This should be equal to the non-linearity. What was the non-linearity? Tan x. This is equal to tan x. Now we have two unknowns, v1 dash and v2 dash, two equations, first and second. Using basic elimination method, we'll be solving these two equations and find the value of v1 dash x, v2 dash x, and then by integrating them we get v1x, v2x, and putting the value of v1x and v2x in this function, we get the particular solution, and hence using that particular solution we get our general solution. I hope that was clear. So firstly we'll solve the equations first and second. So solving first and second. So we'll multiply the first equation by a sin ax. That would give us a v1 dash x cos ax sin ax plus a v2 dash x sin square ax is equal to 0. And now multiplying the second equation by cos ax, we get minus a v1 dash x cos ax sin ax plus a v2 dash x cos square ax is equal to, now sin x is, tan x is basically sin x by cos x, and multiplying it by cos x, the terms cos x gets cancelled out, we are left with sin x. Now adding these two equations, we get this gets cancelled out, we are left with a v2 dash x times sin square ax plus cos square ax, which we know that is equal to 1. So this is equal to sin x, which implies v2x is 1 by a times integration of sin x with that this is sin ax ax. So integration of sin ax is minus cos ax by a. Therefore v2x is equal to minus cos ax by a square, which implies, now this gives us that v1 dash x is equal to minus v2 dash x sine ax by cos ax. This came from equation 2, no, equation 1. Now putting the value of v2 dash x from here, we get minus sine square ax by a cos ax. Now integrating this, we get v1x is equal to integration minus 1 minus cos square ax by a cos ax dx, which gives us minus 1 by a integration of secant ax dx plus 1 by a integration of cos ax dx. Now we know that the integration of secant x is log secant x plus tangent x. So this gives us, this is equal to minus 1 by a log secant ax plus tangent ax divided by the constant plus 1 by a. Now what is the integral of sine cos ax? It is sine ax by a. Therefore, v1x is equal to minus log secant ax plus tangent ax by a square plus sine ax by a square. Now putting the value of v1x and v2x, we get y px is equal to log secant ax plus tangent ax by a square plus sine ax by a square times y1x. Now what was our y1x? y1x was cos ax. This times cos ax plus what was our v2x? v2x is minus cos ax by a square. Uh, this is minus ax by a square times y2x. What was y2x? Sin ax. Sin ax. Now this gives us the particular solution. Therefore, our general solution is yx is equal to by cx, that was c1 sin ax plus c2, let's make it same, c1 cos ax plus c2 sin ax plus this ypx. I hope this was clear. We had the main important thing that one should remember is that v1 and v2 satisfies this type of equation. y1 dash, sorry, v1 dash y1 plus v2 dash y2 is equal to 0. And the second one is v1 dash y1 dash plus v2 dash y2 dash is equal to the function f, that was the non-linearity. Here it was tan x. Okay, so next we'll again see some another question, another equation that could be solved using the method of variation of parameters. So next we have question number 8, which is solve y double dash minus 2y dash is equal to e power x cos x by using the method the method of variation of parameters. Solution. Again, we'll start with finding the complementary function. For that, we need the auxiliary equation. So our auxiliary equation is given by auxiliary equation r square minus 2r is equal to 0. So this is r minus 2 is equal to 0, r is equal to 0 and 2. We have two distinct real roots. Therefore, the complementary function ycx is equal to c1 e to the power 0x. That means just a constant c1 plus c2 e to the power 2x. Now using these two functions, we'll find the particular solution. So this time our y1x is just 1 and y2x is e to the power 2x. So what was our particular solution? This implies there must exist some v1 and v2 such that ypx is equal to v1x y1x plus v2x y2x is a solution of equation 1. Solution of 1. Where v1x v1 dash x y1x plus v2 dash x y2x is equal to 0 and v1 dash x y1 dash x plus v2 dash x y2 dash x is equal to that non-linearity. So here we have v1 dash y1 was 1 plus v2 dash y2 was e to the power 2x. E to the power 2x is equal to 0. And the second equation is v1 dash times y1 dash. Y1 dash is 0 plus v2 dash y2 dash is 2 e to the power 2x is equal to fx. Fx is e to the power x cos x. E to the power x cos x. So this gives us v2 dash x is equal to e to the power minus x cos x by 2. Now we can simply use the integration by parts to integrate it. This implies v2x is equal to 1 by 2 e to the power minus x as it is cos x as it is e to the power minus x by minus 1 minus integration. We start with let I is equal to integration e to the power minus x cos x by 2. Now derivative of cos x is minus sin x e to the power minus x by minus 1. This gives us minus cos x e to the power minus x by 2 minus integration 1 by 2 sin x e to the power minus x dx. Now we'll again use the integration by parts and somehow we'll get back to the term I. This is equal to minus e to the power minus x cos x by 2 minus 1 by 2 sin x as it is e to the power minus x by minus 1 minus integration. Derivative of sin x is cos x e to the power minus x by minus 1 dx, which is equal to minus e to the power minus x cos x by 2 plus e to the power minus x sin x by 2 minus I, because this is the same term. So on left hand side we had I, this gives us 2I is equal to e to the power minus x sin x minus cos x by 2. This implies what was our I v2x. Therefore v2x is equal to e to the power minus x sin x minus cos x by 4. Also from equation 2 we have v1 dash is equal to minus v2 dash times e to the power 2x, which is minus what was v2 dash? V2 dash is e to the power minus x cos x by 2 times e to the power 2x. Now this is minus e to the power x cos x by 2. Again we'll use the same method to find the function v1. Let I is equal to minus 1 by 2 integration e to the power x cos x dx. This is equal to minus 1 by 2 cos x as it is integration of e power x minus integration of derivative of cos x is minus sin x, so this turns out to be sin x e to the power x dx. Again using integration by parts, x into x by 2 minus 1 by 2 sin x as it is e to the power x minus integration of derivative of sin x is cos x e to the power minus x. This is minus this minus cos x e to the power x by 2 minus e to the power x sin x by 2 minus I. So this gives us 2I is equal to minus e to the power x cos x plus sin x by 2. Therefore, 2x is equal to minus e to the power x cos x plus sin x by 4. Now putting the value of v1x and v2x in the definition of ypx, we get ypx is equal to minus e to the power x cos x plus sin x by 4 times some 1, because y1 was 1, plus what was our v2? v2 is e power minus x sin x minus cos x e power minus x sin x minus cos x by 4 times y2. What was our y2? y2 was e power 2x. So we are left with e power x minus cos x minus sin x plus sin x minus cos x by 4, which gives us ypx is equal to, this gets cancelled out, minus 2 e power x cos x by 4, or simply 2. Hence, our general solution yx is equal to ypx plus ypx is equal to, what was our ycx? c1 plus c2 e to the power 2x, c1 plus c2 e to the power 2x minus e to the power x cos x by 2. So this is our general solution. I hope all the steps were clear. There was not much ambiguity. Even if you have some doubts, you can, I'll be posting this recording on the YouTube. You can easily just comment and let me know if you have any doubt. Let's move to the last question for today's lecture. Let's solve y double dash minus 4y is equal to sine 2x. Again, we'll start with finding the complementary function and then find the particular solution. Solution. So the auxiliary equation is given by r square minus 4r is equal to 0. This is just 4. This gives us r is equal to plus minus 2. So we have two distinct real roots. This gives us that the complementary function ycx is equal to c1 e to the power 2x plus c2 e to the power minus 2x. Next aim is to find the particular solution. Again, the similarly, as we had a specific case when the nonlinearity is e to the power ax, we knew we can find the particular integral by just putting the value of d to be equal to a. Similarly, for the case when we have non-linearity of the form sine ax or cos ax, in that case we just replace d square by minus a. So let's see how we'll find the particular integral in particular solution in this case. The function by px is equal to sine 2x by d square minus 4d, not d, just 4. Now we'll see whether we can replace d square by minus 2. Minus 2, not minus 2. We'll replace d square by minus a square. D square is replaced by minus a square. So this is minus 4. So we can put d equals to minus 4. The denominator will still be non-zero. So y px is equal to sine 2x by minus 8. Therefore, general solution yx is equal to c1 e to the power 2x plus c2 e to the power minus 2x minus sine 2x by 8. I hope all the steps were clear enough. If you have any kind of doubt, please let me know. I will try to solve that issue in the next class. But even if it is a small, silly doubt, please don't hesitate. Please let me know so that while starting the next class, I'll start with your doubts and then we'll move forward to the next sections. Okay, then let's finish it here and let's meet again next Friday. Thank you.